Vertical wind turbines. Due to their futuristic design, they often look fantastic. Therefore, some people may want to have a vertical wind turbine for their commercial building or private house. In order to generate electricity in an environmentally friendly way, we often receive emails with the question of whether vertical small wind turbines are recommended. Admittedly, the market for small wind turbines is confusing. There are not only many suppliers, but also different designs and types of wind turbines. After this video, you will know the most important facts about vertical wind turbines, technology, advantages, disadvantages, and their economic efficiency as mini power plants. Let's start with some fundamental aspects of vertical wind turbines. The overall look of a wind turbine depends on the orientation of its rotor axis. We categorize turbines as either horizontal or vertical. On the left, you see a turbine with a horizontal rotor axis, indicated by the black line, and on the right, one with a vertical rotor axis. The placement of the rotor axis plays a crucial role in shaping the rotor, determining its rotation plane, and influencing its capacity to convert wind energy into electricity. There are two primary types of vertical wind turbines, one of which is the Darius rotor, named after its French inventor, whose patent was filed in 1925. The Darius rotor comes in various subforms, including helix-shaped, disc-like, and the H rotor with straight blades. These turbines typically have three slim rotor blades driven by lift forces, allowing them to achieve high speeds. The aerodynamic properties, including wind pressure and lift effects, contribute to their efficiency, reaching the maximum of around 40%, with the physically possible maximum for wind turbines being 59%. The Savonius rotor represents the second primary type of vertical wind turbines, characterized by its comparatively massive and drag-driven design. Unlike the Darius rotor, it operates at lower speeds, rotating at a maximum equivalent to the wind speed. Consequently, Savonius rotors exhibit lower efficiencies, with a maximum rotor efficiency of less than 20%. Now, let's compare the structure of traditional horizontal wind turbines. They operate on lift, enabling them to achieve high speeds, with rotor efficiencies reaching up to around 50%. This efficiency is near the physical maximum of 59%. Shifting briefly to the historical context of vertical wind turbines, they are not a recent innovation but, in fact, the oldest type of wind turbine. The Persian windmill, dating back to the 7th century, attests to their historical roots. The 1970s marked the inception of modern wind power technology, leading to diverse designs for both horizontal and vertical wind turbines. Notably, even industry giants like Vestas, the current global leader in megawatt wind turbines, explored vertical wind turbines in the past, but focused on bringing horizontal variants to the market. Let's move into the key technological aspects of vertical wind turbines. Examining the aerodynamics of wind turbines with a vertical rotor axis, consider the rotating Darius rotor. When observing its movement in the wind direction, the right part is wind-driven, while the left side moves against the wind. A notable aerodynamic drawback compared to horizontal turbines. This counterwind movement results in energy loss due to wind resistance. In summary, the aerodynamic challenge for vertical wind turbines lies in part of the rotor moving against the wind, presenting a significant disadvantage compared to horizontal counterparts. Although Darius rotors demonstrate good efficiency, vibrations and resonances pose complications, necessitating additional precautions and limiting the use of higher masts, particularly in small wind turbines at many inland locations. In the realm of vertical wind turbine technology, wind tracking plays a crucial role in accessing strong winds. Unlike horizontal turbines that require alignment through mechanisms like wind vanes, vertical turbines, with blades on all sides, eliminate the need for wind tracking. While this absence of wind tracking seems advantageous, it overlooks a significant drawback. Vertical turbines, by absorbing wind from all directions, lack the ability to turn the entire rotor away from the wind, a crucial feature for storm protection. Now, let's explore the benefits of vertical wind turbines. Firstly, let's discuss sound development. Vertical turbines are generally a bit quieter than their horizontal counterparts. This is mainly due to the slower rotational speeds of vertical wind turbines compared to small horizontal wind turbines. Another advantage of vertical small wind turbines lies in their high acceptance and popularity. Vertical wind turbine often attract significant attention due to the aesthetic design of the rotors. This aspect holds significance for building and licensing authorities. Lastly, vertical wind turbines offer an advantage in terms of maintenance and repair. Components, such as the generator, are conveniently located near the ground rather than at the top of the mast, as seen in horizontal wind turbines. Let's explore the competitiveness of vertical wind turbines in terms of both economics and technology. The economic success of a wind turbine relies on its ability to generate electricity at competitive costs. Small wind turbine owners benefit significantly from lower production costs, potentially undercutting the energy supplier's prices. Economic efficiency is determined by two factors: electricity yield and total costs. Electricity yield depends on wind potential and overall turbine efficiency, influenced by factors like longevity and availability. Total costs include the initial investment and ongoing operating costs, emphasizing the importance of stormproof and high-quality technology for optimal performance. Calculating the cost of wind power involves dividing total costs by electricity yield, resulting in euros per kilowatt-hour. Horizontal turbines often prove more economical due to superior electricity yield and comparable costs. Technical quality is crucial, especially in storm conditions, with successful outdoor operation over months demonstrating a turbine's maturity. Buyers should seek manufacturer-independent references to gauge storm-proof performance. In conclusion, horizontal small wind turbines emerge as the more economical choice due to their capacity for generating higher electricity, benefiting from aerodynamic advantages and regulatory simplicity. These turbines, prevalent in the market, are widely accepted and often certified under the rigorous standard. Their efficiency and ease of regulation make them the preferred option for electricity generation. On the other hand, vertical Savonius rotors, while exhibiting lower efficiency, find niche applications in specific contexts, such as pumping water. However, a major drawback is the scarcity of manufacturer-independent references, leaving potential buyers with limited information. This lack of transparency impedes decision-making regarding the effectiveness and economic viability of these rotors for widespread electricity generation in inland areas. Similarly, Darius rotors, distinguished by lift efficiency, face challenges related to pronounced vibrations and difficulties in storm protection. The limited ability to turn a vertical wind turbine out of the wind, a feature found in horizontal counterparts, further complicates their use. Despite these challenges, both vertical designs share the advantage of easy maintenance, with machine components conveniently located on the ground. The aesthetically pleasing designs of many Darius rotors contribute to their positive reception in certain settings. We are thrilled about the future development of vertical small wind turbines. What innovations will emerge to tackle these technical challenges? One thing is clear: the enthusiasm for vertical wind turbines is immense, and the demand is growing. We would be happy to see vertical small wind turbines become even more popular, and we'll make sure to keep you informed, especially about the exciting developments in vertical wind power. Stay tuned for updates.